In this problem, I'll talk about the conservation of charges. So we have two objects here, A and B, and these two objects have initial charges. Object A has 50 microcoulomb charge, the positive 50 microcoulomb charge, and object B has negative 10 microcoulomb charge. And these two objects are rubbed against each other. Whenever the rubbing process happens, that means the charges transfer from one object to another object. Whenever I say the charge transfer, that means the electron transfer from one object to another object. Remember, I said electrons, not the protons. The protons do not transfer. And the question here is why? Pause this video and think, why does the proton do not transfer? Why does the electron only transfer? The answer is the protons are inside the nucleus and the electrons orbit around the nucleus. So the electrons transfer, not the protons. Okay, so now after the charging process, the final charge on object B is now negative 20 microcoulomb. And now you have to find out what is the final charge on the object A. So the beauty of this charge transferring process is the total number of charges before and after has to be exactly equal. The total number of charges is always conserved. That is why it is called conservation of charges. Okay, the charges cannot be lost. It has to remain exactly the same before and after the charge transfer takes place. So here it is, the total charge before rubbing is equal to total charge after rubbing. This is coming from the conservation of charges. So now let's say before the charge rubbing process, we have Q1 and Q2, Q1 and Q2, and after rubbing we have Q3 and Q4. And the Q1 is 50 microcoulomb and Q2 is plus negative 10 microcoulomb. Q3 we do not know, and Q4 is minus 20. And if we solve, we get the 60 microcoulomb. And now if you have 60 microcoulomb and then the minus 20, then you see it has 40. And if you add them together, you see the 40. That means the total charge has remained conserved. Okay, so for now we found out the total amount of charge onto this object after the charge transfer took place. And now let's see what happens to the number of electrons after rubbing. If you look at the object B, the object B has become more negatively charged from minus 10 to minus 20. What does that mean? This means the object B has received more electrons. Okay, so this one was positively charged and this one has negatively charged. So when we rub them together, that means the electrons were transferred to this object. The electrons, the negative charge were transferred to this electron. Okay, that means this one lost electrons and this one received electrons. That's the reason it got more electrons, that means more negative charge. And the object A lost electrons, that means it becomes more positively charged. That's the reason it has now 60 more positively charged, 60 microcoulomb, and this one becomes more negatively charged because it received electrons. Okay, so that's what it says. Object has become more positively charged, means it has lost electrons. And now let's find out how many electrons are transferred to this object, or how many electrons did this object A lose, or how many electrons the object B received. So for this one, we're going to use the conservation of charge. And so here you can use the object A or object B, that's entirely up to you. the amount of charge gained by object A is 10 microcoulomb. That means it has lost 10 microcoulomb. That means it has lost the electrons. So this is the change in charge, not the actual. That's the change in the charge, change. So from quantization of charges, Q is equal to N times E. And I'm going to solve for N. And here E is the charge of the electron, the magnitude of the charge of electron or proton. That's the magnitude of the charge. Charge of electron or proton. So if I solve for N, because we know the value of Q, which is 10 microcoulomb, that's the change in charge, and the charge of each electron or proton is 1.6 times 10 to the negative 19, and with the value of N, we get is 6.25 times 10 to the 13. What does this mean? This means the electron, the object A has lost this many electrons. Object A has lost this many electrons, or in other words, the object B has gained this many electrons. It has to be exactly equal. Okay, so this object A has lost, and the object B has gained exactly this many electrons. Now if you look in terms of the masses, which I mean, this is not the question asking, but I'm giving you a little bit more information about this one. Now if you think in terms of mass, what is happening to the mass now? So the object A is losing electrons. It is losing electrons, and the object B is gaining electrons, more electrons onto this one. That means the mass of B will go up and the mass of A will go down by exactly the same amount. Okay, because it is receiving more electrons, the mass will go up, and as it is losing electrons, the mass will go down. But the total mass again has to remain exactly the same. It's just the mass transfer or the charge transfer. So this is it from this conservation of charge. If you have any questions, let me know. So please do not forget to like, share, and subscribe the channel. Thank you very much.